Hello there, welcome to Learning Space. Today we'll prove that how root 2 is irrational. So in order to prove that root 2 is an irrational number, we have to be aware about two basic concepts, which is first is a rational number and second is even number. So look here, the standard form of a rational number is P by Q, where P and Q are integers and Q is not equals to 0. One important thing lots of people miss is that in standard form of rational number, that is P by Q, here P and Q, they don't have any common factor, which means this fraction cannot be simplified further. Suppose, what is a simple fraction? Simple form of any fraction is, this is 3 by 4. This cannot be simplified further. And suppose take 6 by 8. This can further be simplified to 3 by 4. So this standard form is like this. It cannot be simplified further. So now look here. What is an even number? So any number that is in the multiples of 2 is an even number. So we have even numbers as 2, 4, right? 6. So let's square this thing, these numbers, these even numbers. Square of 2 is 4, square of 4 is 16, square of 6 is 36. Now look here, these are even numbers and we have made square of these numbers. So here square of 2 is 4, which is also an even number. Square of 4 is 16, which is also an even number, and square of 6 happens to be 36, which is also an even number. So we can say the square of any even number is even. So only these two things are pivotal in this proof. So now let's proceed with our proof. So we prove this root 2 is irrational by the method of contradiction. In contradiction, we first assume that root 2 is irrational first, and in the end we get to know that it doesn't qualify as a rational number. So that if it is not a rational, it is an irrational. I oftenly ask my students, a person who is not regular, he is called as an irregular person. Suppose a person is not responsible, he is irresponsible. Similarly, a number which is not rational is irrational. So let's prove this. First we have to assume, let's assume that root 2 is rational. So if root 2 is rational, we can represent it in the form of P by Q. So let's represent root 2 in the form of P by Q, right? So when we represent this as in the form of P by Q, you have to be aware that P and Q are integers, Q is not equals to 0, and P and Q don't have any common factor, as we discussed in the basic concepts in the beginning. So we'll square the both sides. On squaring both sides we get 2 equals to P square by Q square. I will just get p square equals to 2q square. We have come in the half of the proof. This is our first equation. So we got our first equation as p square is equal to 2q square. So from this we can say p square is in the multiples of 2. So we can say p square is an even number. Is even, right? If p square is even, p should also be even, right? So we'll do one adjustment. We'll represent p in the form of even number. Suppose p is equal to 2x. As p is an even number, we can represent it in the multiples of 2. X is some integer. So we'll put this value in equation 1. Put in equation 1. So from equation 1 we'll get what? 2x square is equal to 2q square. We'll continue with the calculation. 4x square is equal to 2q square. And now we'll get what? Q square equals to 2x square. Now pay attention. Here q square is in the multiples of 2. So q square must be an even number. And if q square is even number, then q is ought to be an even number. So q is also an even number. So now look here, we get a contradiction here. P and q both have turned to be even number. And if we get a fraction where numerator and denominator both are even, it can be simplified further. If these are even, this contradiction that this is in the simplest form, p and q don't have any common factor, we get to a contradiction when we assume that root 2 is irrational. So in end we can conclude that both p and q have turned to be even, which contradicts the initial assumption that p by q was in its simplest form, that is p and q have no common factors other than 1. Since our assumption that root 2 is irrational, our assumption root 2 is irrational leads us to a contradiction. We conclude that root 2 is an irrational number. I hope that makes sense. And one more thing, we can do this with many numbers except the complete square numbers. We'll write numbers from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So let's take root of these things, these numbers. So since 4, 9, these are perfect square numbers, we can say this root, even root 1 is a perfect square number. So root 2, root 3, root 5, root 6, root 7, root 8, root 10 can be proved as an irrational number. I hope that makes sense and helps to you. Thank you so much. Have a good day.